seamounts that we are diving on were once active volcanoes, but they are quite old. So Kelvin Seamount has not been directly dated before, but based on the ages of nearby seamounts, I would estimate it to be about 92 million years old.
And as we explore the floor here of Kelvin Seamount, we have a variety of scientists on shore who are participating in this exploration as well. They are connected to us on the ship via an instant messaging system, what we call an event log.
Yeah, and very rarely have I actually seen one moving like this. So,
yeah, Chris, if you look at this,
definitely a cool shot. So thank you.
I don't think we've seen such well-developed ripples on any of the sediment surfaces.
Certainly not over such a broad area. We've seen a few in small patches that have been next to rocks, but not an extensive area like this. So this is really interesting. We have just tremendous diversity. There's not a lot of numbers of each of the species, but there's a lot of different species here. So that's one measure of biodiversity, is just how many different species we see. It's something called species richness. Yeah, these bamboo coral whips can grow up to more than 15 feet tall. There's a nice red-colored anthropod there. Anthropods, again, are crustaceans. They're paracarid crustaceans, so they have what's called a marsupium below the main part of the body there, and the females will hold the eggs while they develop in a little pouch, just like a kangaroo does. So we've seen several different kinds of polyps, including sea anemones. Now we're seeing a polyp of the group Hydrozoa. And Hydrozoa is where you find your siphonophores, your Portuguese man-o'-war. So this is a single polyp. You can see it's got a ring of tentacles. It's got a column, a soft body that's attached to the substrate. Really nice view in the Sirius camera if you want to see what the Deep Discoverer looks like when it's working on the bottom of the ocean here, and you can see really well the slope as well of this feature.
Yeah, it looks like
how
a
steep it
debris,
is.
almost sort of a debris slope here.
Swimming thing, yeah, look at that. What is that? Looks like a little butterfly. Oh, everybody's been asking about the pteropods. Here's a pteropod. I told you it's called a sea butterfly, and there it is. So this is a snail. This is a snail that is adapted to swim in the water column.
This is Chris at the museum at the Smithsonian. That is Evoplasoma, the coral predator.
Okay. So is that?
And so if you noticed what it's at the base of, which is that other coral there, I think that you could easily cue the Jaws music because it's moving up on that thing. I bet it's about to feed.
I have to say, what gets me really excited is when I see a lava flow that has these really distinct features on it that can let me imagine what it looked like when it was actually erupting. To get a sense of how the rheology of the lava, how it flows, that at one point this was not solid rock, this was actually moving and changing its shape. I just find that really exciting about volcanology in general.
Well, it's been an outstanding dive, and perhaps all the more remarkable given that at about 6:30 or 7 this morning, we didn't know that we would have a dive because the Gulf Stream was moving through the area so rapidly that we weren't able to work here because the ship wouldn't have been able to be stable enough for the ROVs to work on the bottom.